Welcome back to this explainer. Today, we're diving into what is basically the body's ultimate biological speed limit, its internal red line. If you've ever pushed yourself hard on a run, on a bike, or really in any demanding physical activity, you've actually interacted directly with the incredible science we're unpacking today. We're going to explore the biology behind endurance, decode our physical limits, and really look at the exact science of the lactate threshold. So let's start with a feeling I'm pretty sure you know well. Why do our bodies suddenly just hit a wall during intense exercise? You know the exact feeling I'm talking about. Your muscles start burning, your breathing gets impossibly heavy, and honestly, no matter how much willpower you muster, your body just screams at you to slow down. Well, that feeling isn't just a lack of motivation, right? It's a very specific biological problem happening right there at the cellular level. And it's exactly the problem we're about to solve together. Okay, let's dive into this. Here is our roadmap for today. First, we'll cover the body's energy systems, then we'll define the lactate threshold, and after that, we'll step straight into the lab to prepare, conduct, and analyze a real-world test.
All right, Section 1, the body's energy systems, fueling the machine. So every single movement you make requires adenosine triphosphate, commonly known as ATP. But get this, our bodies only store about 85 grams of it at any given time. That's literally roughly the weight of a deck of cards. So to keep moving, we intuitively shift between three different energy systems, kind of like shifting gears on a bike, totally based on the demand of the activity. First up, you have the ATP-PC system for those short, explosive sprints. Second is the glycolytic system, which kicks in for intermittent, hard intervals. And third is the aerobic system, which is that steady, reliable engine we rely on for long endurance exercise.
Now, the aerobic system is incredibly efficient and sustainable, but it definitely has a limit. When you demand energy faster than that aerobic system can possibly produce it, your glycolytic system is forced to step up and pick up the slack. It's fast, sure, but it's way less efficient. And, crucially, as it burns fuel to give you that much-needed energy spike, it produces a byproduct that your body has to continuously clear out from the blood and working muscles. That byproduct is lactate. Think of it like bailing water out of a leaky boat. As long as you bail faster than the water comes in, you stay afloat. Which brings us to Section 2, defining lactate threshold, the tipping point. Here is the exact scientific definition. The lactate threshold is the point during incremental exercise when lactate builds up in the bloodstream at a higher level than resting values. It's that precise, critical moment when the accumulation simply outpaces the clearance. Your boat starts taking on water. And the reason this matters so much is that this specific threshold is actually one of the absolute most common and effectively used performance markers for both recreational runners and serious elite athletes trying to map out their endurance capabilities.
Section 3, preparing for the test. We're stepping straight into the lab.
So to actually find this invisible line, a lab requires some very specific, highly clinical apparatus. You need an exercise station. Typically, that's a treadmill or a Monarch cycle ergometer. Then you absolutely need your data trackers, like a heart rate monitor and a stopwatch. And finally, for the blood work itself, the lab uses a lancet to draw the sample, a cuvette, swabs, and the real star of the show, the Dr. Lang's lactate analyzer. The absolute centerpiece of this whole operation is that Dr. Lang's lactate analyzer, specifically the Lactate Scout model. This highly sensitive, handheld little device is the crucial tool they use to measure the blood samples drawn at regular intervals during the test. It gives the sports scientist real-time data on the exact lactate concentration in the athlete's blood as they're working. But hold on, before the athlete just hops on the bike and starts pedaling, there are some pretty strict pre-test considerations. The subject absolutely must perform an adequate warm-up of about 10 minutes. Why is this mandatory? Well, two massive reasons. First, it allows the oxidative energy pathways, specifically the mitochondria, several minutes to reach their optimal operating capacity. Without a warm-up, the body relies way too heavily on glycolysis right out of the gate, giving a totally false high lactate reading. Second, it calms the nerves. Being nervous actually increases circulating levels of epinephrine, which can also trigger increased glycolysis and totally ruin the baseline data before you even start. Which leads us right into Section 4. Conducting the lab test, the incremental push. So, the incremental protocol works a little bit like this. It's actually performed pretty similarly to VO2 max testing if you've ever seen one of those. You start the athlete at a relatively low baseline work rate. This is absolutely vital to establish a resting baseline before things get hard. Then, you incrementally increase the intensity, typically about every 4 minutes. At the end of each 4-minute period, you draw a quick blood sample. You just continue this slow, steady progression until the subject is at or near exhaustion, which usually takes about 12 to 20 minutes to finally reach that threshold. Finally, we reach section 5, analyzing the results, finding the breakpoint. To really grasp what the data means, you need to know the baseline numbers first. Under normal, resting conditions or during super low-intensity training, blood lactate is typically sitting right around 1 to 2 millimoles per liter. But during an intense, exhausting effort, that number can absolutely skyrocket to over 20 millimoles per liter. It's a massive, spectacular physiological shift happening inside the body.
And this brilliantly illustrates what we're looking for. When mapping out power in watts alongside heart rate and blood lactate concentration, scientists are hunting for a very specific breakpoint. They're looking for the exact moment where blood lactate concentration increases by at least 1 millimole per liter in 2 consecutive stages. For example, if you see a clear 1 millimole jump right at 250 watts, followed by another jump at 275 watts, then boom, you can meticulously pinpoint this individual's lactate threshold right around that 250 watt mark.
Actually, a quick point of clarification here, because this is a super common mix-up. The lactate threshold is not the same thing as OBLA, which stands for the onset of blood lactate accumulation. While the lactate threshold is that initial biological breakpoint we just talked about, OBLA occurs when the exercise intensity gets even higher and lactate production completely and utterly exceeds the rate at which it can be broken down. It's defined by a very specific, fixed marker when blood concentration hits exactly 4.0 millimoles per liter. At this point, lactate is fiercely accumulating in the muscle and spilling out into the bloodstream. So, why do athletes and scientists go through all this trouble? Well, it's all about the training data it unlocks. An athlete doesn't just walk away with a pretty graph. They walk away with highly actionable metrics. From this one single test, you can acquire their maximum sustainable power or pace, measure their recovery heart rate speed, pinpoint their exact pace or power right at that lactate threshold, and even calculate a relative index of fitness by dividing their power by their body weight. Honestly, this is exactly why this test is universally considered the ultimate starting point for smart, customized training programs. Which leaves us with a final question for you to consider. How might knowing your exact lactate threshold metrics change your own approach to training and pushing your physical limits? Because when you take the sheer guesswork out of endurance and replace it with hard, cellular data, the boundaries of what your body can achieve completely shift. Thank you so much for joining me on this explainer. Keep learning, keep pushing your limits, and I'll see you next time.